3.1 continued. So now we're going to talk about logistic growth functions. It says let A, B, C, and K be positive constants with B less than 1. A logistic function in X is a function that can be written in the form of either f of x equals c over 1 plus a times b to the x, or f of x equals c over 1 plus a times e to the negative kx. For the constant c is the limit to growth. Or could be called the carrying capacity. So limit to growth or carrying capacity means it can't get any bigger than that, okay? So that means we're going to have a horizontal asymptote up at the top of our graph. So a logistic function looks, you're going to have your asymptote at y equals 0. You're going to have an horizontal asymptote up at your limit to growth, your c value, okay? And then your graph here is going to come up like this, where it will continue, though, on both ends. All right, so example 6 is to graph the function. Find the y-intercept of the horizontal and the horizontal asymptotes. So we have f of x equals 18 over 1 plus 5 times 0.2 raised to the x. Well, remember, your y-intercept is just when x is 0. So let's do that. So we're going to plug in when x is 0. So we're looking for f of 0. And so I'm going to do this without the calculator so we can walk through the steps. So remember, first thing is I need to work in that denominator, right? I just have an 18 on top, so that's no big deal. But the denominator is what I need to work at. I have several things happening, though, in our denominator. So I'll put my 18 over. I have addition, I have multiplication, and I have an exponent. PEMDAS tells us we have to work with the exponent first. So I'm going to bring over my 1 plus 5 times, and what is 2 to the 0? Anything to the 0 is equal to 1. So then we have 18 over. Now in the denominator, I've got plus and I've got multiplication. PEMDAS says to multiply first. So we got 1 plus 5 times 1, which is 5. Then we can add the denominator, so 18 over 6, which is 3. So we have a y-intercept at 0, 3. Now our horizontal asymptotes, we know we're going to have the one that's down at 0, but we're also going to have one up there at that limit to growth or that carrying capacity, the largest it can be, which is that c value, which is what's on top of our fraction, which is up at 18. So when we go to draw this, we have a horizontal asymptote here at y equals 0. We're going to have a horizontal asymptote up here at y equals 18. Our logistics function looks something like this. And we know that y-intercept there, we just said, was at 0, 3. Now granted, mine is not drawn to scale, obviously, but that's what our logistic function would look like. All right, and then example 7, a flu epidemic model. It says a function f of t equals, that equation there, describes a number of people, which is f of t, who will become ill with a flu outbreak t weeks after its initial discovery within a town of 64,000 people. A says how many people were ill at the beginning of the epidemic. All right, so at the beginning means no time has passed. So that means that t is equal to 0. So we're going to look for when f of 0. So we've got 64,000 over 1 plus 4,500 e to the negative 1.2 times 0. So we still have our 64,000 over, we're going to have to work up there in that exponent first, so 1 plus 4,500 e And negative 1.2 times 0 is 0. Now we're doing just like what we did in the previous one there. 64,000 over, we know we're going to do exponents first. So 1 plus 4,500 times e to the 0. Anything to the 0 power is equal to 1. So 64,000 over 1 plus, and we're going to multiply, so we get 4,500. So we got 64,000 over, add them together, so 4,501. And so I'm all about, exact answers and everything, but that doesn't tell me anything about the number of people, okay? I don't understand. I don't know what that is. I can't approximate it. So I'm going to start in my calculator here, and it tells me that it's approximately 14 people. All right, 8 says how many people were ill by the end of the 4th week? Well, the end of the 4th week, then that means that T is equal to now 4. So we're going to find F of 4. So we have 64,000 over 1 plus 4,500 e to the negative 1.2 times 4. Now I'm not going to be able to work this one all the way out without a calculator. But I am going to go ahead and simplify that exponent because it just makes life easier when we go to put it in the calculator. Guys, you cannot, are you listening? You cannot add the 1 and the 4,500, okay? Because the 4,500 is multiplied times that e to the negative 4.8. PEMDAS says you have to multiply those two together first before you can add that 1. So do not put 4,501 e to the negative 4.8. That is incorrect. All right, so now if I'm going to put this in my calculator, I'm going to have to tell my calculator what it needs to keep together. I have just a 64,000 on top, but I have more than one thing in the denominator, so I have to put that denominator in its own parentheses. If not, the calculator is going to take that 64,000 divided by the 1 and add whatever the 4,500 e to the negative 4.8 is going to be, okay? It'll give us the incorrect answer. It's smart. It knows PEMDAS, but it doesn't know what you want to put together before you actually divide. So you have to tell it. All right, so I'm going to type in 64,000 divided by, parenthesis, 1 plus 4,500 times E, which E, guys, is that second LN, okay? Some people like to use the other one, and we found every now and then it's not working. I'm not sure if it's something that people are typing in wrong or whatever, but use the second LN to get to the E, okay? Because it will actually go ahead and open, it'll do the exponent for you, okay? It'll start, it'll ask you what is the exponent. So then you can type in your negative 4.8, get out of your exponent, close your parentheses, and hit enter. And so it should tell us approximately 1,682 people. And then C says, what is the limiting size of F of T, the population that can become ill? Well, the limiting size is that C value, okay, which is the 64,000. And hopefully that makes sense, because if the town only has 64,000 people in it, no more than that number can get sick, right, or become ill. So therefore, that's our limiting factor. That's the limit to growth. This epidemic can't make more than 64,000 people sick in a town that has 64,000 people only.